everyone. Today we will talk about astronomical telescope's second type, that is normal adjustment. That is normal adjustment. Second type of astronomical telescope. So in this, the final image is formed at infinity. The final image we will get at infinity. So we will draw its ray diagram. Similarly, in this, we take two lenses. One is objective lens of large aperture and large focal length, and eyepiece lens, small aperture and small focal length. So we will draw our principal axis. Here are objective lens and here is our eyepiece lens. The object is at infinity. The rays are coming from object. Now we will make it our focus FO. Tick. Then here our image formed. So our image formed at infinity. Our final image is formed at infinity. So the object must be at focus. Then our image must be formed at infinity. So this is also focus for eyepiece lens. So here the image is formed at infinity. So now we will name them. This is FP and this is F0 and this is the angle alpha, angle subtended by object, and this is beta, angle subtended by image. We name it as AB, and now here it is alpha, then it also alpha. Okay, now we will calculate its magnifying power. Magnifying power is what? Magnifying power is angle subtended by image to the angle subtended by object. So we take its tangent. Magnifying power is equals to tan beta upon tan alpha. So in triangle AC1B, tan alpha is equals to AB upon C1A. Okay, and this is triangle AC1B and AB upon C1A. Okay, similarly in triangle AC2B, tan beta is equals to AB upon C2A. So magnifying power is equals to AB upon C2A, C1A upon AB. So we get C1A upon C2A. What is C1A? What is C1A? That is minus F0. And what is C2A? That is FV. So magnifying power is माइनस एफ नॉट अपॉन में एफ वी. Now we will calculate the length of telescope. This is the length of telescope. Length of telescope is equals to L is equals to, what is length of telescope? FO plus में FV, that is focal length of objective lens and focal length of eyepiece lens. This is the length of astronomical types normal adjustment. Okay, now we will talk about some conditions. How can some conditions for a good telescope? We will talk about conditions for good telescope. Okay, here some. A good telescope has high magnifying power, high resolving power and high light gathering power. That is, a good telescope has high magnifying power, high resolving power and high light gathering power. Now first we will discuss about magnifying power. We know that magnifying power is equals to minus f naught upon में fe. So the magnifying power will be high. कब magnifying power high होगी? तब हमारी फोकल लेंथ जो है ऑब्जेक्टिव लेंस की लार्ज होगी और आई पीस लेंस की स्मॉल होगी. मैग्नीफाइंग पावर will be high if focal length of objective lens is large and eyepiece lens is small. Okay, if the focal length of eyepiece lens is small and focal length of objective lens is large, then we get a high magnifying power. Second one is resolving power. नेक्स्ट क्या है हमारा रिजॉल्विंग पावर. रिजॉल्विंग पावर हमारी होती क्या है? इट इज द रेसिप्रोकल ऑफ द लिमिट ऑफ रेजोल्यूशन ऑफ टू फार ऑब्जेक्ट्स. व्हाट इज रिजॉल्विंग पावर? इट इज द रेसिप्रोकल ऑफ द लिमिट ऑफ रेजोल्यूशन ऑफ टू फार ऑफ ऑब्जेक्ट्स. इट इज द रेसिप्रोकल ऑफ limit of resolution of two far off objects. Now resolving power is equals to 1 upon में limit of resolution, that is 1 by d theta, or we can say that d upon 1.22 lambda. These are theoretical. You know the limit of resolution's derivative. Here d be the diameter or aperture of objective lens, and lambda be the wavelength of light. So from this resolving power will be high if aperture of the objective lens is large and wavelength of light is small. Resolving power of the telescope will be high if aperture of the objective lens is large and wavelength of light is small. This is the resolving power for telescope. The resolving power of microscope, similarly you can calculate this. I can tell you directly, 2 mu sine theta upon में 1.22 lambda. This is the resolving power for microscope. Now the last one condition for a good telescope is light gathering power. Light gathering power. Light gathering power is directly proportional to the area of objective lens. Light gathering power is directly proportional to area of objective lens. So light gathering power, I'll name it with short or make it easy. So directly proportional to area. So area of a lens is pi d square by 4. So light gathering power will be high if the aperture of the objective lens is high. Light gathering power will be high if aperture of the objective lens is large. So these are conditions for a good telescope. First one is magnifying power, second one is resolving power, and light gathering power. These are conditions for a good telescope. If magnifying power will be high if the focal length of objective lens will be high, or focal length of eyepiece lens will be small. Similarly, the resolving power will be high if the objective lens aperture is large and wavelength of light is small. And in light gathering power, the aperture of objective lens is large, then we get a high light gathering power. If these three powers are high, then we will get a good telescope. So that's all for the day. We will talk about other topics in next video. So thank you for watching my video.